Alright, good morning, good afternoon, good evening. We've been looking at equations so far, and I believe we have a clear understanding of what absolute value equations are, of what radical equations are, linear equations, and so forth. So I have a couple of equations written to me, or maybe which are spotted out from your worksheet 2. So worksheet 2 BS 140, worksheet 2. So if you look at the question 1 there are a number of questions which involves equations which you're supposed to be able to solve out. So the question says solve the following equations, and if you look at the question 1, we've solved a number of questions as we are looking at absolute value equations. We've solved a number of questions as we are looking at radical equations. So I've just pointed out tomorrow which we didn't look at on question 1, involving equations, which is involving rational equations and the like. So let's look at how we can solve the selected ones given to us here on the board, where we are being told that we're supposed to solve the following equations, such as x plus 3 power 3 over 2 equal to 8, the absolute value of x squared plus 6x equal to 3x plus 18, which is also an absolute value equation. I'm sure you have an understanding of how to solve that one. Then say there's a radical equation. This D is a rational equation, and this E is also something which involves radical equations. So let's see how basically we can able to solve these ones. So starting with the simplest one, x plus 3 power 3 over 2 is equal to 8. I'm sure you can relate. There's an example we did last time concerning radical equations for solving this one. So we want to find the value of x. So how do we find the value of x? The instance of us finding this value of x, we have to make sure that this power is deleted. So I'm going to simply say, okay, this is the same as saying x plus 3 power 3 over 2 multiplied by 2 over 3. This is the only way I can delete this power. But whatever I do to my left hand side, we do it to the right hand side, raise it to a power 2 over 3. So I'm simply saying we're deleting this radical first, so that this and this will go and I'll remain with the 1 here. So remaining with the 1, I'm going to just have x plus 3 to be equal to 8 power 2 over 3. Now, according to indices, we know that the denominator is the root and the numerator is the power. So this is just the same. Say x power 3, the cube root of 8, your answer, raise it to a power 2. So that you can have x plus 3 to be equal to the cube root of 8, which is going to be a 2, and 2 squared is going to be equal to what? 4. So I have x plus 3 equal to 4, where x will be equal to 4 minus 3, which is basically just equal to a 1. As simple as that. So the first equation has been handled. So if you are involving equation which involves such a power and a constant on your right side, your aim is to delete that radical first by raising it to an appropriate power. Okay? So we have another one there now given to us. X squared, the absolute value of x squared plus 6x should be equal to 3x plus 18. The absolute value of x squared plus 3x should be equal to 3x plus 18. How do we handle that one? Number one, recall that this is an absolute value equation. So if you've not gone through the video on absolute value equations, this is not your video. You have to go back and look at all the absolute value equations you solved in the previous videos, and also radical equations as well. So the absolute value in this case equal to that. This means that x squared plus 6x should be equal to the positive of 3x plus 18, or x squared plus 6x to be equal to the negative of 3x plus 18. So that we can have, so this equation which will be formed as x squared plus 6x minus 3x minus 18 is equal to 0, or x squared plus 6x is equal to negative 3x minus 18, so that you can have x squared plus 6x plus 3x plus 18 is equal to 0. So we have two kinds of equations now given to us to say how do we solve these two equations. Yeah, so now we're going to solve these two quadratic equations. So this is x squared, this is what, plus 3x minus 18 is equal to 0, I think. Or, and then this one is x squared plus 9x plus 18 is equal to 0. So what are we talking about now? We're talking about two values which when added will give us a positive 3, but when multiplied will give us a negative 18. What values are those? The 6 and the 3. So x squared plus 6x minus 3x minus 18 equal to 0, so that we can have x, open bracket, x plus 6 minus 3x plus 6 equal to 0, so that we can have x minus 3 and x plus 6 is equal to 0. What I do here, I'm simply factorizing this quadratic equation. We are solving by factorization. Solving by factorization, this is what I'm doing here. Sometimes the question can come, we either give a quadratic equation solved by factorizing. So we factorized it, then we saw that we can find the values of x. So the values of x will be x minus 3 equal to 0 and x plus 6 equal to 0, so that we can have x is equal to positive 3 and x is equal to negative 6. These are the values of x. The same is happening this side. Two numbers multiplied they give you 18, but when added they give you 9. So those values are 6 and 3 again. So it will be 6 squared plus 6x plus 3x plus 18 is equal to 0. Here it was 1 was negative, so that you can have a negative 18. But here both of them should be positive, so that you can have a positive 18. So that we can have 6x plus 6, 3x plus 6 equal to 0. This is a positive. So we can have x plus 3 and x plus 6 to be equal to 0. So we can have x plus 3 equal to 0 and x plus 6 equal to 0. So we can have x is equal to negative 3 and x is equal to negative 6. These are the values of x in this case. So now, according to this equation, which is an absolute value equation, how many values of x do we have? We have 3 values of x. We've been told x is equal to 3, negative 3, and negative 6. These are the values of x which we have found. But every time when it comes to absolute value equations, what are you supposed to do? Test these values. Because there are cases whereby one value is invalid, or maybe sometimes even all the values can be invalid. So you test your values. How do you test your values? Get these 3, insert it in there, and compare if your left hand side is equal to your right hand side. Get this negative 3, put it in there, compare if your left hand side is equal to the right hand side. If that is the case, if the left hand side is equal to the right hand side, then this is correct. You test again for this one. If the left hand side is equal to the right hand side, then this is correct. The same as that value. So this is how we'll be able to handle absolute value equations. I'm sure you can relate even from the previous videos we've made under absolute values. So we have another one there where we're being told that 5x minus the 26 plus 4 is equal to 6. Is equal to x. Find the value of x. How do I find the value of x? Number one, what kind of an equation is this? A radical equation. So how do we solve radical equations? The previous video under radical equations. Be able to follow it through, understand how to solve radical equations, and practice more radical equations. So we simply say that make this expression the subject. So it's meaning that everything which is not a radical can go to the other side. Meaning that I'm going to have 5x minus 26 can be equal to x minus a 4. Next step, make sure this radical is deleted. How can I delete it? By raising it to an appropriate power. Whatever I do to this side, I do to the other side. Squared, squared, so that this and this can go. I'm going to remain with the 5x minus 26 is equal to, this can be expanded, x minus 4, x minus 4. So that we can have 5x minus 26 is equal to x squared minus 4x minus 4x plus 16. Like terms together, I can take everything this side, meaning that I'm going to have x squared. This is minus 8x. When this one crosses, it becomes minus 5x plus 16. When this one crosses, it becomes positive 26. Well, okay? So that we can have x squared. This and this, it is minus 13x. Am I correct? Yeah. X squared minus 13x. And this is 16 plus 26, giving us what? Yeah, so 16 plus 26, we're going to have, this is a 42. So we're simply saying this expression is all equal to 0. So factorizing this, two numbers giving us negative 13 when added and when multiplied will give us a 42. What are those numbers? So talking about the numbers being what? I think 6 and 7. So both of them should be negative for this to be positive and this to be negative. So we're going to have 6x squared minus 6x minus 7x. 6 minus 7 is negative 13 plus 42 is equal to 0. So that we can factor out. So by factorization, this is x minus 6. This will be negative 7. X minus 6 to be equal to 0. So that we can have x minus 6 and x minus 7 to be equal to 0, so that we can have x minus 6 to be equal to 0 and x minus 7 to be equal to 0. X is equal to positive 6 and x is equal to positive 7. These are the values of x for our radical equation. So now there are cases whereby you fail to find your factors, because not all equations, quadratic equations, can be solved by factorization, because it will be difficult to find some factors. So don't be afraid to go to your formula method. I'm sure you remember the formula method for quadratic equations. Don't be afraid to go to that. Embrace it and solve it well. We have another one. What kind of equation is this? Rational equations. Rational equations. Where we're being told that 2 over x minus 4, x minus 2 is equal to 1 over x minus 4 plus 2 over x minus 2. So how do I handle that one? So rational equations are those form of equation which has variable in the denominator, or maybe a fraction form in the fraction form, where we have variables in fraction forms. So these are rational equations. So first step, how do I handle rational equations? First, aim to simplify everything to be a single fraction. Now this is a single fraction, it is okay. But when you look at your right hand side is a double fraction. We have two fractions from the right hand side. So what do? I have to express my right hand side as a single fraction. What in principle am I using to express it as single fractions? Addition of fractions. So under rational function, at least you have to know when to add, when to subtract, when to multiply, and division of fractions. You have to be able to know how to solve this. If you do not know, I'm sure you still have some books and grades too. Yeah, so you can be able to, you can be able to go through them. Just try to search through, since you are even Paris so you're able to go through those grade 2 books what you were doing addition and subtraction of fractions. Yeah. So now let's start. Expressing my right hand side as a single fraction, lowest common denominator between this and that, it is basically x minus 4, x minus 2. So the product of this can be my lowest common denominator, and this remains a single fraction the way it is, x minus 4 x minus 2. So this into this. So we're simply saying this going into this. This is like x minus 4, x minus 2. What is going into this is x minus 4. So we're dividing by x minus 4. So when this divides x minus 4, this goes, what am I going to remain with? It is the x minus 2. So that is why we're simply saying that x minus 4 into this, we are remaining with the other guy, x minus 2. So remember, it's the answer multiplied by the numerator. This is a 1. So 1 times the answer is 2x minus 2. The same is happening, x minus 2 into this. This cancel, I'm going to remain with x minus 4. But keep in mind we're multiplying by the numerator. So it is positive 2 multiplied by the answer, which is x minus 4. Keep in mind I've put my parentheses, my brackets, so that I should take care of my signs here. X minus 4 should be taken care of. This whole expression is being multiplied by the numerator 2. Continue. This will be x minus 4, x minus 2 to be equal to x minus 2 plus 2x minus 8 over x minus 4, x minus 2. Well, okay? So that by the end of the night we can have x minus 4, x minus 2 to be equal to what we have. Like terms there, x plus 2x, this is 3x. Negative 2 minus 8, this is negative 10 over x minus 4, x minus 2. Now, if you look at this equation, the denominator are not impressed, it's not impressing us. So what do? We have to get rid of the denominator. Every time you're solving rational equations, every time we try by all means to get rid of the denominator. So how do we get rid of the denominator? By multiplying by the reciprocal of that. So getting rid of this denominator, I have to multiply both sides by that denominator. So if I multiply my left hand side, I say x minus 4, x minus 2. This multiplied by 2 over x minus 4, x minus 2. This is my left hand side. The same is happening on my right hand side. I'm supposed to multiply by the same denominator, which is 3x minus 10 over x minus 4, x minus 2. Remember these two, the left and the right hand side, they have the same denominator. No wonder whatever I do this side, I do it the other side. So I'm multiplying by x minus 4, x minus 2. Remember this is over 1. This is over 1. Multiplying by this, the denominator here and this will cancel. What am I going to remain with on my right hand side? On my left hand side, I'm going to remain with the 2 alone because the denominator have cancelled out. So let me delete this part. So what do I have? This goes, I'm remaining with the 2. But on my left hand side, this goes and this goes, I'm remaining with the 3x minus 10. Then we can solve it like terms. This goes to the other side, goes 2 plus 10 to be equal to 3x over 3 over 3, and the value of x will be equal to 12 over 3, which is x is equal to a 4. As simple as that. So what do? You delete your denominators. We only delete the denominator by multiplying both sides by that denominator, so that it can cancel out. Or others will tell you to say, when you reach at this stage, you cross multiply and then you simplify things later on. It's still okay. But usually sometimes mathematics just simply say, how do I get rid of this? Just multiply both sides by that denominator so that it goes away. Even if you cross multiply here and then simplify, you'll still end up with the same expression, same answer, same value. So that is our value of x. Now we have another one there. How do I solve this one? So with this one you have to be very much careful. So how do I handle it? First thing, you have to have the knowledge of factoring expressions. Do you know how to factor out expressions? That's the first principle supposed to be able to know there. If you're able to know how to factor out expressions, then well and good. So how do I handle this one? Recall, when it comes to factoring out, I'm sure when we had maybe 2x squared plus 4, most of the times, how did we factorize this one? Oh, we simply say, which one is common? We'll look at the common items. We discover that the common items in the first term and the second term is the 2 and the x. The 2x is factored outside, so that you can remove the x plus 2 in brackets like this. I'm sure you can recall factorization, how we were factorizing in grade something. Factorization. So how was the factorization coming about? So we simply said that when factoring out some expressions, we always factor out the term with the lowest power. So we factor out the common term with the lowest power. That's how we factor out. Remember, this is 2x squared, this is 4x. The x is common, the x is found there, and the 2 is in there, and the 2 is in there. But why did we just decide to factor out the 2x? We always factor out the 2x because the x which has been factored out, we didn't want to factor out x squared, but we factored out the x which has the what? The lowest power. No wonder x, the lowest power, is factored out. So how did we remain with these two? We simply divided this by the common factor, we remain with the x. Divided this by the common factor, we remain with the 2. So this is the principle we're trying to handle there. So the only way this can be solved, it is through the factorization, using the factorization method, us knowing the concept of factoring out. Well, okay? So we have to know the concept of factoring out. Though we can still look at it again, maybe in terms of solving it in terms of radical equation. We know when it is 1/3 and when it is 4/3. Those concepts, I'm sure we have ideas about. We know how to handle them. So we can still handle it in terms of radical equation, but there are those situations where we're supposed to be able to know which one is the best solution and the simplest solution of all. So if you look at such an equation which is in this format, first of all, think of it as factoring it out. So if I was to factor out, I look at my first term and the second term, I can factor out, I'm seeing something common here. What is the common thing which I'm seeing? I'm seeing a 2, which is a common factor of 4 and 6. So 2 can be factored out. What else am I seeing? I'm seeing an x. So x can be factored out. What else am I seeing? I'm seeing the x minus 1. Now, on the x minus 1, what power is the x minus 1 going to have? Remember, factoring out a common term with the lowest power. Should it be x minus 1 power 4/3 or should it be x minus 1 power 1/3? It will be power 1/3. There's an x squared, there's an x here, but I've decided to choose the x with power 1 because the lowest power between x squared and x power 1 is x power 1. No wonder x power 1 has been factored out. So x minus 1 here, it's common on both sides. But I'm choosing to factor out that one which has the lowest power, which is the 1/3. Yeah, okay? So this is factored out. We open our bracket. What is now going to remain inside here? If I divide this by 2x, what do I remain with? I remain with my 2x like that. This divided by this, there is a 1, so it is the 2x just which is going to remain. Plus 6x is divided by this 2x, I'm going to remain with the 3. This divided by that, what am I going to remain with? I'm going to remain with x minus 1. So now, when you look at this divided by this guy, this is more like x minus 1/3, 4/3, divided by x minus 1 power 1/3. How do I divide these two? I'm looking at the concept of indices. Same bases, you just subtract the what? The powers. So I'm just looking at 4/3 minus 1/3. This is just the same as saying what? A 1 which is going to be formed. So the outcome of this is basically x minus 1 power 1. This is the x minus 1 which we're talking about, power 1, like this, which is the factored. We factored out this, and this is the factorized expression which is going to remain in the brackets. So remember, this has been factored to that. Sometimes the question can just come to say like this, and they don't say factor out this expression. Factor this expression. How do you factor out? You look for the common terms, common items. The common items in this case is, I'm looking at the x appearing on both sides. So what is going to be factored out is the x with the lowest power, not x squared, but x power 1. I'm looking at the 2 which can go into both 4 and 6. 2 has come out, so I'm going to remain with the 2x here, because there's a 2x has been factored out, and 2x are factored out here. I'm remaining with a 3. Remember, 2x times 2x is giving me 4x squared. 2x times this 3 is giving me 3x. This 2x is the one that has divided this to give me that. But for the x minus 1 here, this is a common thing, but we factor out the lowest power. The lowest power, it is 1 over 3 and not 4 over 3. So lowest power comes out. So dividing this by the lowest, the common term, I'm going to remain with a 1. So 1 times 2x is still a 2x. But dividing this by this guy, I'm going to remain with x minus 1. Remember, this expression was equal to what? 0. Well, okay? So this expression was equal to 0. Like that. So this is just the way we solve quadratic equations. Once we factor, we solve by factorization. What do? We equate each and every factor to what? To 0. So we factored out. So we have the first factor, this one, and the other factor, which is this one. So connecting the factors to 0, what do we have? We have 2x, x minus 1 power 1 over 3 to be equal to 0, or we have 2x plus 3x minus 1 to be equal to what? 0. So that we can now solve for x there. Solving for x, what am I going to have? We can have, this is the same as saying over 2x over 2x, so that I can have x minus 1 power 1 over 3 to be equal to 0. This is a radical equation now. Delete this by multiplying by a 3, multiplying by a 3, so that this goes, we have x minus 1 to be equal to 0, and x could be equal to positive 1. Well, okay? So if that is the case, the same is happening with this guy. How do I handle this one? I'm simply saying that this is 2x plus 3x minus 3 to be equal to 0. The 3 can go to the other side. This is 5x is equals to positive 3 over 5 over 5, and the value of x is equals to 3 over 5. This is another value of x. So how many values of x do we have now? We have x equal to 1 and x equal to 3 over what? 3 over 5 as our values of x. As our values of x. So now, actually, just on this part, 2x that. So we have to understand that. Let me just take it up afresh from here. We have the first factor, which is 2x, x minus 1 power 1 over 3. So this is equal to 0. This factor is equal to 0, and this factor is equal to 0. So this factor will yield to these results. But look at this factor. So again, and there's an understanding whereby these two, again, we can simply call them to be two factors. 2x multiplied by this. So these are two factors again. So we can still break this down to say this is 2x equal to 0, or this is x minus 1 power 1 over 3 is equal to 0. This is another way. So that in this case, we are going to use to what? X to be equal to 0. Or in this case, we're going to use to what? Power 3, so that x minus 1 can be equal to 0 and x is equal to 1. So that we can have 3 values of x for this question. So we are going to have 3 values of x. X equal to 0, x equal to 1, and x equal to 3 over 5. Now, remember the rule is that when you're solving radical equations, when you're solving absolute value equations, always test these values. There can be a possibility that one of them can be correct. There can be a possibility that none of them cannot be correct. So you test them. For example, you set your 0 in there to see if it is going to yield positive results. So if I insert my 0 there, what am I going to have? Testing for x equal to 0. I'm going to put my 0 in the original equation. So I have 4, 0 squared, 0 minus 1 power 1 over 3 plus 6, 0, 0 minus 1 power 4 over 3. The answer should be equal to what? 0. Now this is 0. 0 times anything, this is already a 0. This is 0. 0 times anything, this is already a 0. So automatically 0 is equal to what? 0. So the first value of x, where x is equal to 0, is valid. The same is happening when you put in your 1 in there. So when you put in your 1 here, it will be 1 minus 1, which is going to give you a 0. 0 times this, it's 0. This is 0. Still going to be valid. The same you test for 3 over 5. So, very important as well that you test in your values when it comes to radical equations. So, this is some of the practice questions under equations. Some of the important equations are supposed to be able to take note of. So, look out from the next video where I'll look at more questions under Worksheet 2. We'll be able to solve and revise together in this week. Thank you very much.